All right, we are resuming section 8.2.2, complex roots. Your job was just to go back and do 8-82, and if you needed help, do 83, 84, and 85. Find a method that works best for you. Remember, the question was, if you have these two complex roots, what's the equation that they came from? Okay, what are they roots of? And if it didn't make sense, or you kind of want to check your work, we're going to start with 8-83, okay? And what they were talking about in 8-83 is, well, let's actually work backwards. We know that if we have this equation, x squared minus 6x plus 25 equals 0, we know we can solve that. We can use the quadratic formula. We can use completing the square. When we solve it, we get these two solutions. Now, in the previous video, we talked about sum and product. We did that for a reason, okay? The sum of these two solutions, okay, simple, that's just 6. The product, not quite as simple, but the product, not going to have space there. If I multiply these things together, I'm going to get 9, and the two corners of the generic rectangle that I'm multiplying with are going to cancel each other right out. And I'm going to get 16i squared. Okay, I squared is -1, changes to 9 plus 16, which is 25. Okay, and you might have a different way to do it, but you should be able to get that the product of these two is 25. If you're not able to do that, make sure you email me so I can help you out. Sum is 6, product is 25. What does that have to do with our original equation? 6, I see right here as the b value. Notice it's not just 6, it's the opposite of 6. Okay? The product, 25, is the c value. So if I want to write an equation, and I know the two roots that are complex, we'll worry about where the a value comes from later, but the b value is the opposite of the sum, and the c value is just the product. Okay? If you like that method, great. Use it. Go back and do number 82. Use that method. The slight problem with that method is that it's very much memorizing a rule. If you're really good at memorizing a rule, great. If you're not, that might not be the best method for you. 8-84 is showing you a different way of doing the same kind of problem. And again, this person was just thinking about an easier example. If I know that x equals 3 and x equals -5 are solutions, meaning here's my graph, it crosses at +3, it crosses at -5. That's so easy to write an equation of, okay? I can put y equals x minus 3, x plus 5, done. And I can multiply it out and get it into standard form if I need to. So if we use the same concept here, if I take x, now notice we switch signs here. This was 3, so we put x minus 3. This was -5, so we put x minus a -5 or x plus 5. So I have to change the signs here. X minus 2 minus I times x minus 2 plus I. Please take your time when you're doing this step. So many students, when they're rushing through this step, will not change both signs, or maybe they get this a positive. Just take your time, okay? And a reminder, this is going to look a little crazy, but a 3x3 generic rectangle is going to help us multiply this out. The answer is going to be actually not so bad. The work might just seem like it to start with. Okay, just a generic rectangle. 3 parts here, 3 parts there, and we're going to start multiplying. So I get x squared minus 2x. X times I, it's just like if I had a times b. Okay, multiply those together. Straight across, -2x, +4, -2i. On the bottom, positive times negative is negative, x times I, xi. Negative times positive, 2i, negative times negative, I squared. Okay, and you're going to notice some things are happening here. You should notice that these corners, xi, negative xi, 0 pair and gone. 2i, negative 2i, 0 pair and gone. Okay, then as a reminder, I squared is negative 1. So we've got a negative, negative 1, which is really a positive 1. So I have x squared, I have negative 4x, and I have 4 plus 1, or 5. Okay, that's strategy number 2 for writing an equation given two complex roots. This is probably the longest strategy. It's probably the most algebraic strategy. Last one, 8-85. Most students find this one to be the one that they like the most. They find it the easiest. So this person has written, instead of writing the two roots out separately, negative 4 plus I and negative 4 minus I, they've squished it together with the plus or minus. And they're going to kind of undo until they get to an equation. So we are going to first add 4 to both sides. Okay. Then we're going to square both sides. And you can multiply that out to x squared plus 8x plus 16 if you want to. But oftentimes we write quadratic equations in graphing form that looks like that anyway. Now, it doesn't matter really if this was positive or negative, because when you square anything, it's going to become positive, so to speak. Positive I squared is I squared. Negative I squared is negative I times negative I. That's also positive I squared. Okay, so either way, it's going to be an I squared on this side. What does I squared equal? Okay, that's just a fact of math you have to know. Okay, and then one more step, I'm going to move the 1 to the other side. Of course, when I move it to the other side, I'm adding it. So now here is my equation in graphing form. You guys know how to move it to standard form if necessary. Multiply x plus 4 times itself, add the 1, you will get x squared plus 8x plus 17. Either answer is fine, just depending on the directions. So now you have 3 methods when you're given two complex roots on how to work backwards and find the original equation. If you have not already done so, you need to go back and do, really it's 8-82. You need to use one of those strategies. If you want to practice using all 3, practice the couple that you like. Make sure that you go back and you write an equation for each of these. Okay, I will post answers below so that you can check and make sure you are correct. Also make sure for today that you are going to Edulastic and taking your 821 formative. That's due at 11:55 p.m. tonight. And also your homework for today is 8-87 through 8-94.